Hi everyone. So in this session, we will have a look at developing a MATLAB code for a swing equation. In the past video, I taught you how to solve the swing equation numerically using modified Euler's method. We are going to use the same methodology for writing the MATLAB code. So if you already have an idea about that modified Euler's method of solving a swing equation using predicted and corrected methods, then it is fine. Else, please have a look at those video and understand the procedure and the methodology involved, and then come back to this video so that you will have a better understanding of writing the code. And writing code also will be very, very simple. Now, I have just listed out the important formulae of swing equation on the left hand side. Three formula: predicted formula and the corrected formula. So our MATLAB code also will be revolving around this. So these lines you have to put into a loop, and you have to do the iteration until a particular time is reached. So let us take that a fault occurs at an instant, and you are clearing by zero point 0.3 seconds. So you can analyze in two ways. You can analyze these set of equations within zero point 0.3 seconds, that is during the fault what happens. You can also analyze what happens when it is exceeding the zero point 0.3 seconds. So this is a very simple method. Only thing is, if you understand the procedure for solving the problem, this code will be easier. If you have no idea about it, then this code seems to be somewhat tougher. So look at this on the left hand side. The first one is predicted value. It is PA equal to, this is PA equal to PM minus P3 max into sine delta. This one is written here. See, this is PA equal to PM minus P3 into sine delta. So here I have given the name as del C of I minus 1. If I take I is equal to 1, then this becomes 1 and this becomes 0. So this equation becomes PA of 1 is equal to, it is PM minus P3 sine, it is delta naught. Okay. Now I'll wrap this. We'll go one by one. Next, the next one is this one, del 1p. So this equation, you can find it here. Okay. So this also, let me rewrite here. It is given like this, del 1p, del 1p. That is del p equal to del naught. See, if one is present here, it should be 0. That is why we have high here and we have I minus 1 here. So 1, 0, I minus 1. So del 1p is equal to del naught plus del omega naught. So it is del omega I minus 1 into step size. This is your step size. This is delta t. And this is del omega naught. This is del, del naught. And this is del 1p, del 1p. So next, next equation, we'll have it for this. So next one is for this. This you can see it here, right? Listen, del 1p, this is del p of I, del omega naught. So that means it should be I minus 1 pi f naught by h. See, pi the 3.14 into 50 divided by h into PA. This is PA. We already written here, no, this PA into step size. This is your step size. That's it. Now, next one, next three lines on a thing. So these three lines are for predicted, no? So these three lines for corrected method. So look at this. This goes for this line. This is stands for this line, and this stands for this line. You can see it is PA equal to PM minus P3 sine del 1p. We are using del p here. And similarly, you can see that it is PA plus PAP into step 6. That's it. So once you finish this, you have to increase your step size and you have to increase your loop count and then you have to proceed this. Here I'm saving it in a variable so that I can use this for I can use it for plotting the graph. That's it. So to be more precise, that's it becomes very simple. To be more precise, these are predictor formulas, and these are corrected formulas. That's it. Now let's have a look at your complete code. See, as usual, we will be getting all the data here. If you want, you can also write a code to calculate all these features. L, else just have a look at it. We'll be getting all the input data here. Uh, Transient internal voltage, infinite bus voltage, PM, and transfer reactance before fault, after fault, during fault, fault clearing time, final time, everything. Now here we are actually assuming the step size, that is delta t, we are assuming it as 0.01. That's all. These are nothing but your maximum values during fault, after fault, before fault, after fault, and during the fault. These are your initial values. Okay, initialization values. And see here you are actually assuming it as del naught, and here you are assuming del omega naught is equal to 0. That's all. Now this curve I just thought this is the curve. Sorry, this code I just now taught you. This is one code, and the same code is repeated again with slight changes, only one change. Now here you are taking the condition when the time is less than the fault clearing time. TC stands for fault clearing time. Before the fault clearing time, what is the condition? And this is nothing but what happens if it exceeds the fault clearing time. That means I told you can observe in two ways. Suppose if the fault is cleared bit less, see, at good fault clearing time is 0.3 seconds. If the fault is cleared in 0.2 seconds itself, then what will be the swing curve nature? If the fault is cleared 0.5 seconds, exceeding the condition, then what will be the nature? That is what that can be observed using these two loops. Only changes here you are using P3 everywhere, no? You are using P3, right? P3 is nothing but that denotes during the fault because fault is happening. If the fault clean time is exceeded, you have to use instead of P3, wherever you have P3, you have to use P2. That's all. So once you finish this, you just plot it, you will get the swing curve. Now just have a look at it. This is your output portion where we have to give all the values. Here I'm giving the fault clearing time as 0.3 seconds and the final time is 1 second. So this is the swing curve. Uh, and as per this swing curve, it is settling down, right? So it does not keep on increasing. That means the system is getting stable because the fault is getting cleared by before the 0.3 seconds itself. Okay. Um, that's it. You'll get a more clear picture if you just do this if you have a hands-on of all these MATLAB programs, then you will be having a very clear picture and you'll become a master in that. Thank you for your listening. Thank you.